For those of you expecting a finished repair video on this one, turn it off now because that's not going to happen. We're going to troubleshoot a turntable. This is an Acoustic Research model ETL1 that was brought in to me from a client in pieces with parts like the motor missing. He brought it in for me to troubleshoot and figure out what's wrong with it. And that's exactly what we're going to do. One thing I dread is when I get things brought to me in pieces, such as this turntable. This is how it came to me. It came to me with like motor and control board removed from the unit. Apparently this went to a shop, and this is how it was handed back to the owner of it, with the platter and everything removed. And he brought it to me like this and asked me if I could mount the motor and see if I could make it work. So it's an Acoustic Research. What is this motor that I've got here? Great, pulley falls off it. It's a synchronous motor. (115 volts, 60 hertz, 300 RPM. So look at this control board here, and it should be able to. It's supposed to be the right board for it. We'll find out pretty quick. Looking at this control board, this looks to be out of a Lin turntable of some type. Looks like there's parts that are missing. Looks like C18 is missing. I don't know what the value of the C18 is. Someone's removed it. I just love it when I get this stuff. Got 4 wires to the motor. They're marked gray, red, and blue. Well, I don't have gray, red, and blue. I have a red, black, and 2 blue. If we measure the motor, there should be 2 coils on this. I think the 2 grays are probably the blue, and the red, or the 2 grays are the 2 blues, and the red is the red, and the black is the blue, I believe. Because when we look on the bottom of this here, the 2 that are marked as gray are tied together, so they would be a coil. So if we measure between the blue and the black here, 150 ohms. Between the blue and the red, nothing. But between this blue and the red, 150 ohms. So these are the 2 coils. So these 2 are going to go together on the 2 gray, and the other 2 should go to the red and the one marked blue respectively. For starters, I see that this cap is not soldered down to the board, so we'll stick that one back down here. I don't know what this other value of cap is going to be. I'm going to have to do some research. So it looks like there's 3 filters that are missing from here. C1, C2, and C18. Big question mark. Wonder if I can find out any info on this. I don't know what the model of this board is or what it came out of. The guy that brought me this, he bought this off, I think he bought it off eBay. That was unsoldered too. That cap there is a little loose in this. So I don't know whether this board works or not, or what the story is on it. I don't even know if it's compatible with this table. And my spidey senses are saying maybe I should walk away from this thing. The last guy that had it walked away from it. I don't really blame him at this point. Although the last guy, from what I understand, is the one who left it in this mess. I guess some research is required to see if I can figure out what the heck this Sondex board is. I take it it interfaces with the power button 33 and 45 speeds on the control panel. Let's take the bottom off this thing and see how this interfaces to the rest of the unit. So I pull the bottom off the unit, and as you'll see, the old motor was actually still in the bottom, still mounted, or just sitting in the base. I've got the base off it now. I'm going to remove the circuit board on here. We'll examine this, but there's no way that this motor is ever going to run, because the motor that's in here is a 12 volt motor. So this is what came out of the bottom of the unit. Yes, I kid you not. There was just two screws holding this in place. The motor was just sitting there, and it's marked clearly 12 volts, 60 hertz, 3 watts, and it's 300 RPM. It's a synchronous motor that's driven by this circuit, and someone's nicely written black or red, black, blue, gray on the wires that they've removed. And as you can see, the traces on here are damaged. There's a transistor that's missing. No power transformer, no AC cord. This is how it was received. And the fellow that worked on it before told him that the motor was shot. Well, first of all, these motors typically will never be shot unless they're seized up. It's an AC synchronous motor. There's nothing to fail in an AC synchronous motor. You give it its AC waveform and it runs. This turntable having two speeds, 33 and 45, the frequency drive would be generated by these transistors. Each bank would probably control one of the coils to produce it would be a sine wave signal to drive this thing. But again, I have no power supply to power this up, so I don't even know what voltage it's supposed to be. It says plus 27, so I would imagine there's a plus 27 here. I would imagine that this 27 volts, wherever that connected here, went in through, I guess this was a regulator transistor of some type. As you can see, the traces are all damaged on this board from the last guy that worked on it. At this stage of the game, I'm really ready to tell the guy to take his turntable back and be done with it. But I'd kind of like to see whether I can make this thing work, because another fellow gave up on it, and the fellow that owns this thing really wants it fixed. So I'm going to reconnect the wires to the board here and try to repair the board, and we'll give it some voltage and see whether I can make this thing actually do anything. What I'm going to do is I'm going to take the traces that are damaged, I'm going to take the wires back to the next good connection point that I can tack them down to for testing. The blue one here, it went back down to, well, it's way down here. So maybe I'll extend that wire a bit. Just so that they're all approximately the same length. That'll do. Now, as far as powering up this board, I don't know what voltage it's going to require. It says plus 27 right here, and that plus 27 appears to go It goes into this regulator transistor here, and it also goes down to drive this IC. So there's a transistor here that's missing. I'm sure it's a regulator type transistor, but I don't know what it was. Q17. I have to do a bit of research and see if I can find the schematic for this and find out what value Q17 was. Looking at the circuitry, the way this is laid out, I think this is actually a regulator, not a transistor. Even though it's listed as Q17, I get a sneaking suspicion this is probably like a 7805 regulator, because the 27 volt supply goes to one pin, the other side is grounded. So that would make this one the output. So I think this is actually a regulator. So I've got an 8 volt regulator. I don't know what voltage this needs, but I don't have a 5 volt regulator. So I've got an 8. So maybe things will work, maybe things won't. I'm not going to hold my breath that this thing's going to do anything, actually, because when things get brought to me that are in pieces, I really, a lot of times, don't hold out a lot of hope that we're going to be able to do anything with them. This one doesn't even have the power supply that's supposed to, be with the unit. It has no power transformer in it or anything. I don't understand how the guy that had it gave it back to him with so many pieces missing. Like, I mean, if I was taking something in to have someone work on it, and they handed it back to me in a box, a bunch of parts that were loose, I think I'd have a few choice words for them. And in the case of this unit here, I probably shouldn't have even attempted this. I should have just, I would have probably been smarter just to tell the guy, sorry, I can't help you on this thing. It's, when someone's taking something apart, I don't really want to do anything to it because I don't really want to be married to this thing, but it'd be interesting to see whether it can be made to work. So I'm just going to power this up with my power supply and see whether I can get any rotation out of the motor. If I can get some rotation out of the motor, then at that point, then it might be fixable. I mean, I don't have the belt or anything. I don't even have the screws to mount the motor. I got nothing. I got the turntable. No tone arm. Well, it's got a tone arm, but it has no needle on it. I don't have the belt for it. I don't have anything. So, as far as I'm concerned, if I can make this motor spin, I'm done with this. I kind of have to prop this thing up like this because the wires from the control panel are not quite long enough to reach this. But let's see whether we get any power first of all. Well, that's a good sign. That means we have power. But I have nothing turning on the motor here. Motor is not moving. What about 45? Oh, 45 is turning. .45 is turning fine. But 33 is not. So we know the regulator is working. Obviously it's the right, or close enough to the right voltage that the unit works. But the 33 speed doesn't. So I guess we now have to determine why the 33 is not spinning. Obviously it's not getting one of the drives. This being a synchronous motor, it's going to take a drive for both the coils to operate, which is controlled through the transistors switching back and forth on this control board. In order to work on this, I'm probably going to have to take these switches out just so that I can operate it without having this big bulk of a turntable sitting in the way. There, that's a little better. Now I have the controls. Give it this power, 27 volts. As you can see, motor turning, motor humming. It just hums. You can feel it trying to turn, but there's no drive. So let's get the scope out, and we'll take a look at the drive to the two separate coils. Make sure we're getting drive for both of the waveforms here. So we'll put the scope into dual trace mode and look at both the drive signals. So here's a look at the scope, and when I turn on the power, as you can see, I have no drive. That's in 33. The motor is just kind of humming back and forth a bit, but there's no drive on either of the coils. If I switch it to 45 RPM, oh, my focus is going out great. Come on, camera. If I switch it to 45, as you'll see, there's our drive signal. And if we bring it up in terms of frequency a bit here, you'll notice that that's how the drive signal is generated between the two phases. The circuitry drives, our circuitry generates a two-phase signal that's out of phase by whatever, about 90 degrees here for our synchronous drive. Because an induction motor, of course, requires a phase difference between the two coils in order to create a rotating magnetic field. And that's in 45 RPM. And even if I stall the motor out, which I'm doing now by holding it by hand, you'll notice that our drive signal is there. If I switch down to 33, we have no drive signal. Or we have something there, but it's not the correct amplitude. And that is the problem with this circuitry. So now I have to figure out why we're not getting a drive signal for the 33 RPM. Which could be tough considering that I don't have a schematic for this unit. And I've looked on the normal spots in the normal websites and I don't find one. If we look at our AC drive to the transistors, when it's running, we've got about 5 volts AC drive on the 45 speed. When I switch down to the 33, it's down to like 1.2 volts. So the drive is missing when it's in 33 speed. So I'm thinking that regulator IC is probably not 8 volts, it might be 12. And I don't have a 12 volt regulator IC. So what I've done is I've got my second power supply, the one I built, that I can set to whatever I want. We're going to give it the 27 volts from the main power supply, the 12 volts for the what I think should be probably my regulated input. And back over to Mr. Scope over here. "33 RPM, 45 RPM. There's our voltage difference. 45, 33, 45, 33. Let's check out the motor. As you can see, the motor is spinning. 300 RPM for 33, and what's that, 450, I guess, for 45. There's our two speeds. Ha 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 ha. Fix this one. I like it. The guy that owns this turntable is going to be thrilled. Now I just got to find him a power supply for it because he doesn't have it, unless he's got it and he didn't bring it to me. As I say, he brought me the turntable in pieces, and he brought me another motor of all things. I showed you that, and it's 110 volt input. It's like, no, that's not going to work. Unless it's really not 110 volts, unless it's really 12 volts and it's marked 115, but he assured me it's the correct motor for the unit, but the label on it is marked 115. And this motor, of course, is fine. It's got plenty of torque on this motor. I don't think there's a problem with it. But I gotta get a 12 volt regulator, and I have to get a power supply capable of delivering 27 volts DC for the main input. But that's got this part of the circuitry working. Here's the 33 RPM. Get 5 volts AC from the transistors, and when we kick it up to 45, it goes up to 7.7 volts. And when we stop it, of course, it goes to 0. So that's got this one working. Now I got to put it together. I got to get a regulator. I can get a 12 volt regulator tomorrow for it, and even get him a transformer, more than likely, or a power supply. I'll give him a call and see whether he's got the power supply for the unit. And for shits and giggles, I hooked up this very expensive Sound of the Wood motor that's listed as saying 115 volts on it. Remember, this is only a 12 volt drive. I wanted to see whether this would do anything. So I've connected it up, and as you can see, it's not 115 volts. It's 11.5. I'm sure it's 11.5, even though the motor itself says 115. Maybe there's a decimal point that's missing there, but that to me looks like 115 volts, 60 hertz. But there's no way in hell that this is a 115 volt motor. And it's not. And it runs. There's the 45 speed, and there's the 33. But I don't think he needs a new motor. The guy that looked at this told him his motor was shot, and he ordered a new motor and bought this motor. Spent $300 on it. Didn't need it. The problem was a problem on the main board itself. The last guy that worked on it kind of butchered the board and didn't know what he was doing. Anyway, I'm going to end this video now because we know that the board works. And all I'm going to do for this, once I get the power supply, I've talked to the guy that owns it. He's got to try and find the power supply now for it, because it was brought to me with no power transformer or power supply. Either way, I either have to find a power supply for it. I'm going to get a 12 volt regulator IC that will fix this board. But we know that the motor spins, and that's what it was brought to me for, was because the motor wasn't spinning. One thing I've noticed is that the original motor has way more torque than the aftermarket motor. Like, I really have to squeeze this thing to stop it. Whereas the aftermarket motor didn't take much to stop it from turning. I think this one's got a longer shaft on it too. I guess yeah, it does. The original motor, the shaft is about 1 millimeter longer. Anyway, as I say, I'm going to end this video here because we've troubleshot this motor, or troubleshot this circuit. Just remember, this thing requires 2 voltages, 27 volts, and it needs a 12 volt regulator. So if you've got one of these boards, I haven't found any documentation. That's the problem, is I couldn't find any documentation for this thing. But yeah, this is a 12 volt regulator. If you get one and it's missing, this is not the right one that's in here. I'm going to be putting a 12 volt regulator in this thing before I send it out of here. I put what I had in there for testing, and it made 45 operate, but the 33 didn't have enough voltage to drive it. So right now we're running it with a second power supply at 12 volts, and it's running fine. So it's going to be a 12 volt regulator I need for this. Get that tomorrow, and that should get this thing up and running, and then it'll go back into the chassis and go back to the client. For now, thanks for watching.